Consciousness is one of the deepest mysteries in science. We experience it constantly, yet we do not fully understand what it is or where it comes from. Most modern explanations assume that consciousness emerges from matter, from neurons, from electrical signals, from biochemical interactions. But this assumption hides a deeper question. Why should matter produce subjective experience at all? Why should electrical activity feel like anything? In this framework, we explore a different starting point. What if consciousness is not a product of matter alone? What if consciousness is related to the structure of space itself? In this model, space is not empty. Space is a continuous, traversable structure. It must maintain its own internal accessibility in order for physical processes to exist. Every particle, every field, every interaction occurs within this structure and modifies it. Time, in this view, is not an independent flow. Time reflects the ability of space to maintain its traversable structure under local physical conditions. When interactions are weak, space maintains its structure easily. Time flows normally. When interactions become strong, space loses effective degrees of freedom. Time slows down. But consciousness does not appear in either extreme. It does not arise in empty space. And it does not arise in fully frozen structure. Consciousness emerges in an intermediate regime, a regime where the spatial structure is highly constrained, yet not fully collapsed. In such a state, space must actively maintain its traversability. This maintenance is not static. It is continuous, adaptive, and internally correlated. These correlations form persistent structural states. Not particles, not forces, but patterns of constrained freedom. The brain, in this framework, does not generate consciousness. Instead, the brain stabilizes a region of space into this intermediate structural regime. Neural activity continuously forces space to remain traversable under constraint. This produces a stable yet flexible structural state. And that state is what we experience as consciousness. This perspective explains several puzzling features of conscious experience. First, continuity. Consciousness feels continuous, even though neural activity is discrete, because the underlying structure being maintained is continuous. Second, unity. Conscious experience is unified, even though the brain is composed of many parts, because the spatial structure maintains global correlations across constrained regions. Third, fragility. Consciousness can be disrupted by anesthesia, injury, or loss of energy, because these conditions either release the constraint or collapse the structure. At the microscopic level, this framework also provides insight into randomness. Quantum uncertainty is not mere noise. It reflects the unavoidable variability in maintaining traversability under constraint. When structure cannot fully determine its next state, probability emerges. This is why consciousness feels stable, yet unpredictable. Why it feels real, yet elusive. Consciousness is not located at a point. It does not sit inside neurons. It is not stored like data. Consciousness is a structural state of space itself, maintained by physical systems. Understanding consciousness, then, may require us to rethink space, not as a passive container, but as an active, maintained structure. And consciousness may be one of the most refined expressions of that structure when space is pushed to its limits without breaking.